Okay, so for the second part of Chapter 2, summarizing and graphing data, the first on your notes is history class. Just as a reminder that histogram consists of bars of equal width
drawn adjacent to each other. I think we discussed that make sure that you have that noted, that in histogram the bars have to touch. So if you're ever having to do a histogram, don't have space between the bars, okay? So your bars are touching. And then on the horizontal axis, that's where you put your quantitative data. We're going to probably put our midpoints there, okay? If you're having to do a histogram. And then remember that the frequency goes on the vertical, okay? And then relative frequency histogram, if you were doing that, you're going to replace frequency with your percents, right? That's the only difference. So let me ask this. So would your actual picture change? So if you did a histogram and then decided to do a relative frequency histogram, does your picture change?
No.
No, why not? Because it's still the same amount. It's still the same amount, right? Yeah. So in this one you actually use the physical numbers, right? But in the relative frequency, it's just the percent, but it represents the same amount of data. So yeah, exactly right. So good. So all you would change is just your scale, right? Whatever you've got written on the vertical axis are good. Okay. So let's look at quickly the example that's actually in your notes. So if we look at, the wrong one. Where'd it go? It's this one. This one. So I'm a really big stickler on when you do graphs to do a proper graph. So what do I mean by that? Well, notice that I have a label on each of the axes there, right? Because we have to know what we're talking about. This is the SAT scores, frequency. I have then what? A title. Every graph is a title, right? So there's some basic stuff that when you're doing a graph for me, I'm going to automatically be checking for to see if you have it, okay? Good. So let's now go to the next one. The next one is, let me just jump down a little bit in the PowerPoint. We just did this last class. Here we go. A frequency polygon. So in a frequency polygon, you use the line segments connected to points directly above your class midpoint values. So, similar to the histogram, we have the midpoints on the horizontal, frequency on the vertical, but now, instead of doing bars, I'm going to have a dot to represent my actual data points with the connected dots. Okay? That's your frequency polygon. This one I won't ask you to draw this one or anything, just we've kind of talked about it, okay? But I'll let you know which ones I need to know specific information about. In your notes, you also have relative frequency polygon. Again, the only difference is you have your percents along the vertical axis. Here's an example here. So they did the pulse rates again. So you have actually two. They compare the women and the men in the example here. Okay. And ogive is the next one. And ogive is a line graph that depicts cumulative frequency. This you will need to know just in terms of the definition. So if you were ever asked what kind of graph could you use to represent cumulative data, then you would say an ogive, right? You don't have to actually draw it, but you do need to have that association with the word, okay? So make yourself a note of that. So then notice that what number again should this graph end on? If it's doing the cumulative frequencies?
Total sample size?
Yes, it should give you your total sample size, right? So in this case, again, it was the pulse rates, they ended on 40, right? So you're going to be going up, and then you'll hit your total sample size. Good. Okay. Dot plot. Dot plot, there's a reason why we like those. Let me go back for 1 second. Let's discuss a histogram again for a minute. Jump back. Okay. So in a histogram, In this first class, what can you tell me about the women with the pulse rates in this first class? What do you know about them?
There's 12 of them.
There's 12 of them. What else do you know?
They're in a certain range,
Okay, what's the range of this class?
60 to 69.
Okay. Now, can you tell me exactly what those 12 women with their pulse rate is?
No.
No. So you do lose some of that when you do your histogram, right? Not that that's a bad thing, but you just kind of have, you're talking in general about that data, right? Here's the difference with a dot plot. So with a dot plot, I'll jump back to it. Come on, there we go. Notice here that we are representing my data, right? And the dots actually represent each of the women. So now, can you tell me how many women may have had like 60 as the pulse rate? 3, right? So now you can actually, you don't lose kind of as much of your data, but you still have a nice little graph. You can still get a good visual looking at the dot plot, okay? So again, by definition, it consists of a graph in which each data value is plotted as a point or a dot along a scale of values. Dots representing equal values are stacked. Okay, so then notice again, I still have this axis label here. And actually, this one from the book will get a -1. What's this one missing, this graph on the board? Title. But I put that in your notes, right? So in your notes, you have the title, okay? And yes, dot plot, you probably want to star, because I would imagine that you might see a question about dot plot in the future, that you may have to maybe do one or know how to read one or whatever with that. So are we okay with how to construct, how to look at a dot plot? Again, you've got your labels on the horizontal. Each dot is a person. Now, there still is a little bit of ambiguity with the information because technically, now we all know, if you remember, what was the max pulse rate for the women? Was what? You remember the number? 124. Yeah. Which, I guess even, I mean, it looks like 124-ish, right? But you don't have the exact number, but still, I mean, it's close enough. But that's what I think of the dot plot. I mean, you still may lose a little bit of what the exact numbers are, but it's still, to me, it holds, it represents your data kind of better than a histogram in terms of what each value is, okay? All right, so dot plot. You need to know how to do that one. A stem and leaf plot. This one you want to also star. What does this do? It represents your data by separating it into 2 parts. You have the stem, and then you have the leaf. So I want to actually look at how did they do this. Let me go back. Let me get some information. Let me go back for a minute. Pause, Terry. Okay, so let me walk you through how you would do a stem and leaf plot graph. So first of all, you would have your stem section and your leaf section. Now, again, we're going back to the pulse rates of the females. What was the minimum number again? Look back through your notes. We'll go back in chapter, first part. What was it, 60, right?
Yeah.
So with 60, the first digit in 60 is what? 6. So I'm going to start my stem, okay, with, what did I just write, y'all?
Steam. Cool, we knew what you meant.
I was like, that doesn't look right. It's not. Steam and leaf. Stem and leaf is where the title. Okay. So we start at 6. Now, what was the maximum number?
124.
124. Now, in this case, it's a 3-digit number. Pick the first 2. So that starts with 12, right? So that's how you actually know what your stem column looks like. You'll start at 6 and you'll end at 12. So just go ahead and just fill all the numbers in. So I've got 6, 7, 8, 9, 10, 11, 12. That's the stem column of the stem, okay? So then what you do, look at your numbers. the first number was a 76, right? So 76 starts with a 7. I'm going to go to my row 7 and then put that last digit, put the 6 in the leaf part. Is that okay? The next number is 72. So I'm in the same row. I'm going to put a what? 2. Next number is 88. So I'm now going to go to the 8th row, put a 8. 60, I put a 0. 72 again. I'm going to do just a couple of these. So I got an 8, 80, 0, 64. I'm going to stop right there. You can do all of the data, of course, right? Is that okay so far? Do you see what I'm doing? Now, this is not the finished product, okay? For the finished one, you actually want to have the leaf part in order, okay? So then you would go back, all right, so that's the first one that I did. So now, my real one, first of all, I would need a what going across the top? Title. I'm going to be lazy and just put title. So you have a title, okay? Then you've got your stem, and you've got your leaf section, okay? Say what? Sure. Yeah, I don't need it. That's fine. So you have 6, 7, 8, 9, 10, 11, 12. So then I would then have this going 0, 4, 8. I would have the 2, 2, 6, 0, 8, and then so forth, right? So then you go back and have this actually ordered. Now, if you don't have a number in that row, that's okay. Just leave it alone, right? So it depends upon your actual values. So you still represent all the numbers from your min to your max over the stem column, okay? And then put your data in. Now, the last thing that you need, because the regular person on the street will be like, what is that? I have no idea. This is the only graph that you need a legend. So make a note, okay? So when you do this graph, you need to have a legend. What do I mean by that? So literally off to the side, you're going to say that this 0, 6/0, that represents a 60 pulse rate. So just let the person know, how am I reading this? What's this? Well, give me just one example. 6/0, that represents what? A 60 pulse rate. So a stem and leaf, you must have a legend with it. That's the only graph that I'll let you have a legend with when you do your graphs. Is that okay? So now when you look back at your class notes, this is now how they got this. This is the pulse rates of females. Notice all the leaves are in what? Third order, right? Now, the nice thing about a stem and leaf plot, you don't lose any data, do you? I have the exact values of everything written in this graph, okay? So that could be helpful, especially to me if you're trying to see if you have a number that's repeated often. That can be hard to see sometimes if you're just looking at your data kind of everywhere, right? But can you now quickly see where you have some repeated values? Oh, yeah. You see all these 2s, all these, yes, you can now easily find your value that are repeated as well. That's helpful with the stem and leaf plot. Okay?
How would you do that if one of your values was a decimal? Would you round?
Start at 0?
I think what they would have you do. I don't think that any of the examples that I have you do would do that.
So you just put a dot in the number in the leaf section. Like if it was like 6.3, but 6 and the leaf was 0.3.
We just put 0 in the tens, eh?
Well, not if it's like 7.5 or something.
Or 60.5.
Yeah.
Let me research that. Let me research it for stem and leaf if you would even use this to represent, or how you use it if you have
Values.
non-whole numbers. Because in all the examples, they're all whole numbers that you work with. So let me look at that. I'll come back to you on Monday about that. Okay?
When you do your legend, do
Yes.
you have to start with do you have to list your men as the legend, or can you list any one of them?
I could have put 1/2 means 12.
Okay.
Just something they know how to read it.
Okay.
So yeah. Good question. Let me jump that down. Let me see. When you have non-whole numbers, how would you do your stemming? Okay. So I'll get back to it now. Other questions? Are we all okay? Because again, can't you probably got to do this at some point in time? Do we know how to draw a stem and leaf? Yeah. Okay, good. All right. Go back to the PowerPoint. Let's see. So where are we now? I think we're looking at. Oh, and in your notes, if you forget, we tried to give you some kind of directions or instructions how to do that. So that's also in your notes. I don't know. It says I can label to include a decimal point. So you can do it. I figure I gotta go see how to do it. So apparently you can. That's why I have in my notes here. But we just have never done that example and don't have you do one ever like that. So I will go see how they do that with the decimal point. So good deal. Okay, bar graph. Let me just have to clear the notes for a second because this has a good definition. So bar graph, it uses bars of equal width to show frequency of categories, and this is where I forgot to update y'all to the new terms of categorical. Remember qualitative and categorical, the same thing? I think even in Stat Lab, some of the questions have qualitative. So with the bar graph, I can use categorical data. I'm going to put the different categories on the horizontal axis, and then I still have the frequency on the vertical, okay? With bar graphs, the bars aren't touching, you've got spaces in between them, okay? So just the history specifically that you have to have the bars touching, okay? With the multiple bar graph, you have 2 or more sets of bars, and that can be used to compare your data. So again, just like the histogram, notice I have the different axes labeled. I've got my title still, so everything is still represented in the graph. I think we show one in the PowerPoint, a multiple bar graph that has media income. And so quickly, what can you see from this particular graph? What can you say? What can you assess?
Males make more than females.
That apparently males since 1950, this is some old data, to at least 2000 are making more money. Okay, so again, a bar graph is a quick, easy way to be able to look and compare some of your data. Okay? Pareto chart. Oh, this you will need to know. Oops. Back up. Pareto chart. This is also used with your categorical data, okay? Basically, you guys, it's a bar graph, but it's a specific bar graph. The specific point is your data has to be arranged in descending order. That's the key. That you have to know how to do, okay? So a Pareto, you may need to even possibly draw it. You will definitely have to know, if I say, hey, what chart is always in descending order, immediately you say what? Pareto. Okay. All right. And you've got one on your notes as well. So yes, any questions over bar graphs and then specifically a Pareto chart?
In this one, the bars are touching, but in the one that in my notes, the bars are not touching.
Typically, we don't make them touch when they're bar graphs. Again, this is like the book stuff is just horrible. There's no like labels. There's no type. So that's why I thought I gave nice, better examples in your class notes. Okay. These are pulled out of the book.
So it doesn't matter. A Pareto can either touch or not touch, as long as it's in the
Typically, they don't touch, I think. But it's not wrong. Now, with a histogram, it has to, because here's the deal. Remember, histogram, what's on your horizontal? That's what?
That's your frequency.
That's horizontal. That's your midpoint. That's your actual numerical data that you're talking about there, right? We're not showing gaps because remember that's data that's bumped up to each other. So I can't have gaps in between the histogram, right? Now technically here, I mean, I think it's probably easier to read if they're not all, the bars don't kind of mesh together, right? But no, I mean, it's okay. It doesn't make a difference, I guess, for the bar chart. Whereas histogram, it has to touch. Yes?
In order to get like the frequency polygon, excuse me, can you take the midpoints, like draw a histogram, take the midpoints, put the dots right in the middle of the bar of the histogram bar,
Yeah.
and then just connect them? Is that how you create the frequency polygons?
I mean, you could, but you don't need the bars on there as well. I mean,
Okay.
it's just the dots,
Okay.
so that you could. If you have, that would make it easier to draw in a sense for you, yeah. But yeah, it's just, you don't, I'll just tell you, you don't ever have to draw one for me.
Okay. I had to draw a lot of them in high school. So.
Did you?
Yes.
Yeah, not that particular kind, I would require you to draw. Yes.
If we were asked what kind of chart that was, would it be Pareto just because it's in descending order?
Yes, yes, yes. So you would not just say, now again, bar graph or bar chart is right, but specifically because it's in descending order, the answer is Pareto. Yes. Good question. Good, okay. Let's go on to the next one. Your pie chart, your pie graph, again, bad example. We'll talk about why. From the book, apparently. So let's talk about pie charts. We have that this is also used for your categorical data, right? This is specifically if you want to use to represent the proportions, the percents of your data, you're obviously going to use a pie chart, right? Why? I'll ask y'all, why is this horrible? This right here is just pitiful on the board.
There's no title.
There's no title.
Doesn't have any
There's no percent. There's no, yeah. You would need a key for this. There's no, well, actually, no. They do label it, so, but I have no idea the numbers. So I just have to, I can guess that. Networking, hey, that looks good. It's big. That's all I can say. So this would not be good. Let me show you a better example of what, and start this. You will have to know how to do this one, okay? A much better example is the one in your notes. Okay. Oh, what is we talking about? Hours spent on the home phone after 5 p.m. I have each of my categories labeled with the percents. Now, I do want to tell you this. Pet peeve. You know how you see those circle graphs that have all these colors and they have a legend beside. Pink means this. Yellow means, why do that? Like, just put it on the graph so you have to kind of figure out, matching up. Don't do legends. I don't want the legend for a pie chart. Put the labels on the graph. It's fast, it's easy, and we're done. Okay? So, again, make sure you have percents. Make sure that your categories are labeled. And you need a title. Okay? So, let's talk about, though, just quickly, how do you get the percents? So if you have a bunch of data, how do you transform that into this? So we're going to do an example, an in-class example. And we're going to talk about football for our example. And we're talking specifically about college football. And so I want to know who your team is. So I'm going to start, because we know my team. My team is Auburn.
War Eagle.
Oh, War Eagle. I know, can't see that.
My diagram going to come there too.
Anybody else want to join me in the Auburn group? I've got 3. And I know I have to always put this team up here. Anybody like UT, raise your hand real quick and poll. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Outstanding. Okay. Any Hokies, Virginia, out there? Virginia. Okay. Got it. Okay. Let's see. Just help me. So you just got out a team now. There's lots of teams out there in the world. Oh wait. Let me get one more. Let me get one more caller first. Is there a I don't care group? Yeah, let me have that group first. The don't care. 1, 2, 3, 4. Okay, now, everybody else, who's your team? Let's go.
Alabama.
Really?
Yeah.
Anybody else from University of Alabama? Look at that, look at that. She was like, me. Okay, great. I'm okay with that. It's a free country. The white people like it. Okay, next. Did I miss it? Oh, look at everybody. Everybody? Yes.
I like Texas.
Texas, okay. Good. Hey, bring your team. Texas. Just the one, okay? Longhorn, anybody else? Is that everybody? Get down. You have to participate because you could have been the don't care column. So everybody participated. Okay. So what do you do now? We need the total. So y'all do it. Add it up for me. What's this?
23.
What is it?
23.
I'm getting discrepancy. I heard
22,
23 and
right?
22. 22. Okay, good. I'm not doing it, so I'm just trusting your math. So, how do I make this into a pie chart? Remember, the pie chart, so when I do this, I have to get my percentages. This will be 3 divided by what? The 22. That gives me the percent. So 3 divided by 22. Oh, yeah, we'll just, okay, fine. I'll go with 1 decimal. So 13.6%. That's Auburn, right? So 11 divided by 22, what's that going to be? Yeah, half of y'all. 50%, right? 1 divided by 22. Oh, okay, that's the, well, I got to give you, I got to go to 2 decimals to represent you on the graph. 0.05. Okay, so okay, so what do you then do? You then make your circle. Obviously, this is the UT people over here, 50%, right? And then a little bit sliver. And another little bit sliver, Texas, right? So you know, okay, you got it, right? But that's how you make your pie chart. Because people get home, they're like, people put the number 11 here, like, no, we don't put the numbers, it's the percentage. So I just wanted to remind you of how to get your percents to do your pie chart. We good? All right. Okay. The next one is the scatter plot. Okay. I don't know where to go. I just walked around my head somewhere. Scatter plot. Over here. Scatter plot. So, by definition, it's a plot of paired data with the horizontal x-axis, vertical y-axis. It's used to determine if you have a relationship between 2 variables. We will spend a chapter on this called correlation, chapter 10 in May. No, not May, it's April. We'll get this, okay? So, this one I just find so interesting. So we have the chirps per minute and the temperature. What can you take from this scatter plot? What would you say about this?
It has a positive correlation.
We'll come back to that. Positive correlation, yes. But just in general, we don't know those kind of terminologies. What would you say in regards to the crickets and the temperature?
It's higher the hotter the temperature.
Exactly, the hotter it is, you hear more chirps. And is that not true? Like in those hot summer nights, you hear what? Crickets. Do we hear crickets now? No. It's frozen. I don't know where they are. Like, are they dead or alive? Crickets. Does anybody know if they die off or if they hibernate or like what do they do? Do we know?
Both.
Seriously?
Yeah, they're underground right now, right?
I'm assuming.
I think you're right.
I don't really know much about crickets. This is interesting because I'm trying to figure out. John was saying,
That would be
to count the children. Like, really in the lab is to be like 1,000. And we're like, oh, that's an awful job. But somebody apparently gave us this data set. And so we have this wonderful relationship between temperature and crickets. Okay? Good. Okay. All right. That is your scatter plot.
Yes.
The last one that you had to know, and this one, yes, time series graph, you're going to know this one. This is quantitative data, and the deal is the last sentence on your paper, that's the biggest deal. Time is on the horizontal axis. So if I were to ask you, which graph do you always have time on the horizontal, you say time series graph, right? So in this case, we have the year with our Dow Jones Industrial Average, and we can see the information there. So you may have to do a time series. Okay. Bless you. Any questions over the graphs from chapter 2? Okay, well that officially ends the lecture.